You saw how to compute a 3 by 3 determinant in the previous video, and you probably noticed that it can get kind of complicated. You're going to learn in this video a helpful theorem that can make determinants much easier to compute. Here's what our theorem says. The determinant of a square matrix is the sum of the products of the elements of any row or column with their cofactors. So remember, the definition said we had to use the first row. Sometimes it's better if we pick a different row or a different column to do our cofactor expansion. Let's return to the same example that we saw last time. We have 1, 0, 0, 2 minus 1 minus 2, and then 3, 2, 1 on our columns. Before, we had to take the elements on the first row and multiply by their cofactors. But now using this theorem, and we're not going to prove this theorem, by the way, it can get a little complicated to prove these kinds of things with determinants. And if you're interested, you can look up a proof in your textbook. So instead of doing the determinant with the first row, we're going to do it with the first column. So we're still going to take the elements of the column and multiply by their cofactors. So here's the first element times its cofactor, the A21 element times its cofactor, and then A31 times its cofactor. But what's nice about using the first column is that this element, A21, is actually 0, and so is A31. So if we have a 0 here and another 0 here, that means that neither of these two terms is going to contribute anything to our determinant. That means we don't have to worry about them, we don't have to write out the cofactors, we don't have to do any 2 by 2 determinants. It makes things much simpler. So all we have to do is take the first element, A11, and multiply by its cofactor. So remember, in our pattern matrix from the first video, we had a plus, minus, plus, minus, plus, minus, plus, minus, plus. So this is going to have a plus sign on it. We have 1 times, and now get the minor by deleting the row and corresponding column and taking what's left over. Make it into a 2 by 2 matrix, and then find the determinant. Okay, so I didn't write the 1 down again since we don't need it. But now we need to do minus 1 times 1, minus 2 times negative 2. So this is minus 1 plus 4, which gives us a 3. So you might want to think back to the previous video and remember that when we computed the determinant in the other way, using the first row, we got the same answer for the determinant 3. When you're working through determinants, here's a hint that you might want to keep in mind. You should try to do your cofactor expansion along the row or column with the most zeros. So in this example, I picked the first column since it has 2 zeros for my cofactor expansion. So with this helpful theorem in mind, let's do an example of a 4 by 4 determinant. The first thing to do is to pick which row or column you want to do your cofactor expansion along. So notice that the third column has 3 zeros and only 1 non-zero entry. So we should pick the third row for our cofactor expansion. If we were going to write all of this out, we would have 0 times its cofactor plus 0 times its cofactor, plus 0 times this cofactor. So none of these three elements is going to contribute anything. The only element in this row that contributes anything to our determinant is the minus 3. So we need minus 3 times the cofactor that corresponds to it. And this is the third row, fourth column. So this is the C34 cofactor. So next we need to actually find that cofactor. We're going to delete the third row and the fourth column and then take what's left over. We have a 1, 2, 0 in our first column, and then we have 4, 3, 1 in our second column, and then 5, minus 7, 0 in our third column. And then don't forget about your minus 1 to a power in the front. So here we have minus 1 to the 3 plus 4 power. This will give us a negative. You could also think about the pattern continuing from our 3 by 3 pattern. We would have a plus, minus, plus, minus, plus, minus, plus, minus, plus, minus, plus, minus. So this element here corresponds to a negative sign on the cofactor. And we saw the same thing here when we had minus 1 to the 7th power. Okay. So now we have a 3 by 3 determinant to worry about. We want to pick the row or column with the most zeros. This column has 1, 0. This column has 1, 0. But the third row has 2 zeros. So that's the one that we should pick for our cofactor expansion. So you want to bring down the minus 3 and the minus 1 from here. And then we need to do the cofactor expansion along this row. But this element and this element here won't contribute anything at all to our cofactor expansion, because we'll have 0 times C31, and this will be 0 times C33. All we have to worry about is 1 times C32. Okay. So to find C32, we delete the third row and the second column, and then we find the determinant of what's left over, the 1, 2, 5, minus 7. We also need to decide if this corresponds to a positive or a negative, so you could think back to the pattern, or you can again do minus 1 to the 3 plus 2. So minus 1 to the 5, this is negative, so it'll have an extra minus sign on it. So working through that, we have minus 3 times minus 1 times minus 1. Overall, that gives us a minus 3. Then we need to do the 2 by 2 determinant, so multiply 1 and minus 7, and then subtract the product of 5 and 2. So this gives us minus 7, minus 10, and then working through minus 3 times minus 17. Overall, we get 51 for our determinant. It could be good practice for you to go back to the beginning and do a cofactor expansion along the first row using our original definition of the determinant. So work through all the details and check to see if you get the same answer that we did when we took our shortcut using the theorem from this video.